Mechanics. Problem. Weightless hoop with a point mass on top. A weightless hoop stands vertically on the table, at the upper point of which a small massive weight of mass m is rigidly fixed. The radius of the hoop r. The coefficient of friction on the table is mu. From a very weak push, the hoop begins to move in its own plane. What speed V maximum will the center of the hoop occur by the time the hoop stops rolling without slipping? So this kind of problem we can do using mostly kinematic equations. So first we can count what is the velocity of this weight in a special position using energy conservation, and after that find what is x direction and y direction velocity. After that we can count what is the acceleration in both directions, and after that we can write equations for Newton's second law for this motion, and check how is force of friction consistent with normal force. If it's not exceed by a real equation force of friction equal mu normal force, that will be rolling. And if force of friction will exceed this relation, sliding will start. So that's the main idea. First, let's draw the picture of this process. On this picture we see that after some period of time this weight took position with the angle theta compared to vertical. In this position we can count what is the velocity of this mass in x and y direction. For that we can use kinematic equations. So first of all, check that velocity of center of this hoop is v and it's horizontal. Because we don't have a sliding, we have complete rolling. This mass rotates with a linear velocity equals same v compared to center of hoop. And from this knowledge we can write equations for horizontal and vertical velocities for this mass. So for horizontal velocity we have this expression. We have Vx equal velocity of this center of hoop and the projection of this relative velocity of this mass compared to center of hoop on x direction. That will be V cosine alpha. And this is full expression for horizontal velocity of this mass. Same thing we have for vertical velocity. This is expression for Vy, which is equal projection of this V of this mass on y direction. This is negative V sine alpha. So we have these two expressions, and now we can count what is total V as a function of angle alpha. We can use energy conservation for that. That's the formula. We have full kinetic energy of this mass. We can insert expressions for Vx and Vy in this equation and find that this kinetic energy, and find that this kinetic energy equal mv square multiplied by 1 plus cosine alpha. And from other hand it's equal to potential energy which this mass got from vertical motion. It will be mgr multiplied by 1 minus cosine alpha from this geometry. And after that we can find what is the speed of this center of hoop. We have to divide this part by 1 plus cosine alpha, and we will get this expression. V equal r square root from gr multiplied by tangent alpha over 2. And we can find what is angular velocity. that will be V over R, which is square root from G over R tangent alpha over 2. So that's the main result which we can use in the next step. Next step, we have to count what is acceleration in x direction and y direction to find what are the forces acting on this mass from our hoop. And for that we have to make first derivative for both expressions, for Vx and Vy. Let's do this. So first we have to insert expression for V in these formulas for Vx and Vy, and we will get this formulas. Vx equal this expression and Vy equal this expression. So that's completely a function of angle alpha. Now we have to take a first derivative by time from both parts and put them to expression for forces. So we have these equations. For horizontal force we have this expression, max equal m multiplied by first derivative from Vx by time, which is equal to this expression, and that will be a force of friction, which cannot exceed mu multiplied by normal force. This is our inequality for the horizontal part. For vertical part we have this expression, may equal m dvy over dt, which is this expression, and this force, it's a net force from gravity force, which is minus mg and plus normal force. Now we have to count both derivatives from both these expressions. Now let's count the derivative from this first expression. That will be this one. You can do it like derivative from a complex function, and don't forget in the end to make derivative from alpha by dt, which is exactly our omega angular velocity, which we already counted before. That's this expression. When we put all these things and calculate, we will get later this expression, that mg cosine alpha tangent alpha over 2 less or equal mu by normal force. That's one expression. Let's do a second expression for ay. For vertical acceleration we have this expression. We take a derivative from this expression, and that will be this one multiplied by d alpha over dt, which is again omega, and after simplifications we have this expression, and later this expression. You can check it yourself. And after all, we can simplify this one, because mg we can move to the left, and we have mg multiplied by 1 minus 2 sine square alpha over 2, which is just cosine alpha. And finally we will get that normal force equal mg multiplied by cosine alpha. So we have force of friction has this expression, and normal force has this expression. Let's investigate these things. We know that normal force cannot exceed 0 and be negative. So it means that cosine alpha must be positive, which is true only for alpha less than pi over 2. It means that if alpha greater than pi over 2, we have negative normal force. It means that our hoop will jump in any case for any coefficient mu. But suppose that normal force is always positive. It means that we can insert it in this expression, and after that cosine alpha will cancel, and we have expression for angle like this one: tangent alpha over 2 less or equal mu. It means that hoop will jump when tangent alpha over 2 exceed mu. So that's a critical angle. And now we can count what happened in both cases. What is the speed of our center of hoop in this case when mu greater than 1, or in this case when mu less than 1. We can use this formula to count what is the result. So first result will be when cosine equal pi over 2. It means that tangent equal pi over 4 equal 1, and we have speed equal this expression. For mu greater than 1, v equal square root from g over r. And for mu less than 1, we have this expression. So that's the solution for our problem.